Hello and good day dear, welcome back to another tutorial in properties of materials by Smart Bukites. In this tutorial we are solving a question under elasticity whereby we are told a cylindrical specimen of metal alloy given that the diameter is 10 millimeters is stressed elastically, that's elastic stress, in tension given a force of 15,000 Newton. And this force reduces the diameter, that's that earlier 10 millimeters, by 7 exponential negative 3. That's the change in diameter after applying that force is 7 times 10 to the power of minus 3 millimeters. We are told to compute the Poisson's ratio given that the Young modulus or modulus of elasticity is 100 gigapascal. Simple, we can do it, but before doing it, kindly subscribe to Smart Bukites YouTube channel if you haven't done so. Then press the bell icon so that you'll be notified whenever we upload our next video. If you have subscribed, we are told in the video to determine Poisson's ratio, which we know that is the strain resulting from the change in diameter, which is Ex, over the strain resulted by change in length, which is Ez. For example, in the xy plane, if we call this to be z and we call this to be x, the change in diameter is going to be in this direction and the change in length is going to be in this upward direction. Now let's find the strains. For the strain resulting from the change in diameter, we can say it's the change in diameter over the original diameter d0 or d. We both have them from the question, where this is 7 times 10 to the power of minus 3 in millimeters over the original diameter, which is 10 millimeters. Also, the millimeters will cancel out. Therefore, the strain is going to be 7 times 10 to the power of negative 4. To solve our Poisson's ratio, we have Ex now. What of Ez? For Ez, is the strain having direct proportion with the stress? We know that stress is equal to E, the strain. So this is the strain, whereby this is stress and this is the Young modulus and this is what we are looking for. We have the strain but we don't have the stress. But to find the stress, we can say stress is equal to force over area. The area is the area of cylinder. We know that area is equal to pi d square over 4. We have the diameter given from the question, therefore we can say pi multiplied by 10 times 10 to the power of negative 3, since it's in millimeters, divided by 4. Calculating this correctly, you will see that the area is equal to 7.854 times 10 to the power of negative 5 meters squared. We are given the force of 15,000 Newton, therefore the stress is now going to be equal to 15,000 divided by the area, which is 7.854 times 10 to the power of negative 5. Calculating this correctly, you'll see that it's going to be 190.986 times 10 to the power of 6, which is megapascal. Having this, I know that stress is equal to the Young modulus times the strain. Therefore, the strain can now be the stress over the Young modulus, which I all have. Therefore, it's going to be 190.986 times 10 to the power of 6 Pascal divided by the Young modulus, which I'm told is 100 times 10 to the power of 9 because it's in gigapascal. Calculating this correctly, you will see that the strain is going to be equal to 1.909 times 10 to the power of negative 3. This is the Ez. So now the Poisson's ratio, since I have everything, I can say Ex divided by Ez, which is equal to 7 times 10 to the power of negative 4, as I have found earlier, divided by 1.909 times 10 to the power of negative 3. The strain already have no unit, so the Poisson's ratio also will have no unit. This shows that the Poisson's ratio is equal to 0.367. Do you get this also after pressing the calculator? Say it in the comment section and don't forget to subscribe to Smart Bukites.